Today is section 4.4, transformations with matrices. So transformations, if you remember from geometry, are when we take a picture or an image and we can move it around and change it. So this can be very helpful in the profession of animation, which is done on computers now. Pretty much almost any shape can be divided up into little mini triangles, and then in order to make it move or appear to move on screen, they just transform or move those triangles around, which then makes the image appear to move. So very handy if you want to get into the cinematic profession at all. So the first thing we need to know is that the point xy can be written as a column matrix. So you can see that the x is on top and the y is on bottom. So a vertex matrix is used to represent the coordinates of the vertices of a polygon. So all we do is, here's an example. So I have a picture of it, and then I went ahead and labeled the coordinates. And so the coordinates for triangle ABC can be written in the matrix. So when we write it, we write the coordinates of our first point, which is labeled here, so A goes first, and then it's the X and the Y. Then B came second, so I do B next, X and Y, and C was last. So I do C next, which is written here, X and Y. So this is coordinate A, coordinate B, coordinate C. This whole top row right here is my X's and the bottom one is my Y's. Okay, vertex matrix. So then I can use various other matrices in order to transform or move around the image or the pre-image to make an image. Okay, so an isometry is when a pre-image and an image are congruent. So some of our transformations produce an isometry, and some do not. So our first type of transformation that we're going to talk about is a translation. So a translation is when a figure is slid from one spot to another. So it doesn't turn, rotate, or change sizes. It's just moved from one spot to another. We can find this by using matrix addition and a translation matrix to find the coordinates of the new figure. So here's our example. Okay, so we have quadrilateral QUAD, and Q is at the point 2, 3, U is at 5, 2, A 4, 2, D 1, negative 1. Okay, and then it tells me that it is moved by 4 units left and 2 units up. And it wants us to find the new coordinates and then graph the image and the pre-image. So first of all, I know that when we're talking about left, if I move left on a graph, that means I'm moving negative in the x directions. So my x's are going negative. If I were moving right, then I would be moving a positive x number. Up is in the y direction, and it's positive, so it would be a positive y direction. If I was doing down, then it would be a negative y direction. So since I know that, I can write my my matrix for the vertices that they give me. So you can see Q came first, so I listed Q with the X and the Y. Then U, then A, then D. I just listed them down. Then we're going to use matrix addition. Now, my transformation or translation matrix comes off of what it told me. So it said I moved 4 units left, and left is a negative x direction. So all of my x's had to be a negative, and then it moved 4 units. So it was 4 units left, or negative 4 units. And I have 1, 2, 3, 4 columns, so I had to write it 4 times. And then my y's, it was moving up, so a positive 2 units, 1, 2, 3, 4 of them again. So I have enough to add because I can only add matrices with the same dimensions. Okay, so then I went ahead and added. So 2 plus negative 4 is a negative 2. 3 plus 2 is 5. 5 plus negative 4 is 1. 2 plus negative 2 is 4. 4 minus 4 is 0. Negative 2 plus a 2 is 0. 1 minus negative 4 is a negative 3. And negative 1 plus 2 is 1. So this is my resulting matrix. So these are the coordinates for the new image. Okay, and I could list them out. So the coordinates of Q prime would be negative 2 and 5. U prime would be 1, 4. A prime 0, 0. And D prime negative 3 and 1. So if it asks you to find the coordinates, that's what you would do. You would list them out. Q prime, U prime, A prime, D prime, and list them. Okay, so then if we wanted to graph it, flip my page here. Okay, so you're going to graph them just on graph paper. So all you do is plot the points for the first image that it gives you. Make sure you label your points and connect them. Plot the points for the second one that you found. And remember that after we translate it, the points are called primes. So I know that that's the image. Pre-image is just the point. Image gets the primes. And so I plot them and connect them, and then that is my graph. Next one we're going to do is a dilation. A dilation is when the image gets enlarged or reduced, and it's all done by a ratio. So we're going to use scalar multiplication, and the ratio that they tell us to dilate by is going to be the scalar. So for example here, triangle JKL. With J being at negative 2, negative 3, K being at negative 5, 4, L being at 3, 2. And it's dilated, so the perimeter is 1/2. Now I know when I'm talking about the perimeter, I'm just talking about the lengths of the sides. So that means my image is getting half as small, or being multiplied by a scalar of 1/2. So it wants me to find the coordinates of triangle J prime, K prime, L prime, and then graph the image and the pre-image. So I did this. I went ahead and put my scalar, which was 1/2, and I'm multiplying it by the matrix. So J was at negative 2, negative 3, K, negative 5, 4, and then L was at 3, 2. And then you just go ahead and multiply the scalar by each one. So 1/2 of negative 2 is negative 1. 1/2 of negative 3 is a negative 3/2. Yes, you can do decimals. That is quite all right. Half of negative 5 is negative 5/2. Half of 4 is 2. Half of 3 is 3/2, and half of 2 is 1. So you can see I have the resulting matrix here. Now, if it asks you to list the coordinates, you do so by saying J prime is negative 1, negative 3/2 as a point. K prime, negative 5/2 and 2. L prime, 3/2, 1. And then you can see I just went ahead and plotted the points of my original image, plotted the points of my pre-image, and connected them, and there's my graph. Our next type is a reflection. So a reflection is when the pre-image is flipped over a line of symmetry. So we do this by using a reflection matrix and matrix multiplication. Reflection matrices can be a little difficult to find, so we've listed some common ones here for you. So some of the common reflection matrices are the x-axis, this is the x-axis one, y-axis, and then the line y equals x. So these are going to be the ones we use. So our example here today, we have a polygon QRSTU with the points listed here, and we want it reflected over the x-axis. So I always start with the reflection matrix, and since it wants the y-axis, I use the y-axis matrix, and then I am multiplying it by the vertex matrix that I found from all of my vertices. So I just listed Q, R, S, T, and U. And then we go ahead and multiply. So if you remember, I'm going across on this one and down on this one. So negative 1 times 1 is negative 1, plus 0 times 3 is 0. So that gives me a negative 1. Okay, then I go down to the next one here. 0 times 1 is 0, plus 1 times 3 is 3. Moving along, negative 1 times 3 is negative 3, plus 2 times 0 is 0. So that gives me a negative 3. And I've just continued the process all the way along to get this matrix right here. Okay? And so then if it asks you to list the vertices again, then you would do Q prime, R prime, S prime, T prime, U prime, and list them all out, and then graph them the same way as before. A rotation matrix. So a rotation matrix is when a figure is turned around a point. Okay, we find this by multiplying the vertex matrix, or I'm sorry, the coordinate matrix by a rotation matrix. Again, the matrices can be a little difficult to find, so we've gone ahead and listed the most common ones for you here. The rotation matrices, if we have 90 degrees, 180 degrees, and 270 degrees. So our example here, so we have triangle ABC with A being at 4, 3, B being at 2, 1, and C 1, 5. And we want to go ahead and rotate it by 90 degrees. So I've taken the rotation matrix of 90 degrees and I multiply that by my coordinate matrix. So A got listed first, then B, then C. And then I multiply just as before. So 0 times 4 is 0, plus negative 1 times 3 is a negative 3, which gives me a negative 3. 1 times 4 is 4, plus 0 times 3 is 0. So 4 plus 0 is 4. Negative 1, sorry, zoom, stupid camera. 0 times 2 is 0. Negative 1 times 1 is 1. Sorry, I've got to stop pointing so this stupid thing focuses. There we go. Okay. So, anyways, multiplying as always to get this matrix. And so then if it asked for the coordinates, you would have A prime is negative 3, 4, B prime, negative 1, 2, C prime, negative 5, 1, listed in points. And then if it asked you to graph it, you would just plot these points and then plot those points, connect them, and label them as always. And that is all of our transformations for today.